friends, welcome to Nabla Mami Online Maths. Today, we are going to learn how to prove trigonometry identities. And I have 3 trigonometry identities on the board for us to prove. And on the board, the first identity is cos square theta plus sin square theta is equal to 1. Then the second identity is 1 plus tan square theta is equal to sec square theta. Then the third identity is cot square theta plus 1 is equal to cosec square theta. To prove these identities, let's consider the diagram below. I have my y-axis and x-axis. So if I take the origin as my starting point and I open the compass to draw a circle like this, then you see that from this center up to this part, one part of the circumference, is going to be my radius r. So if I decide to draw a perpendicular line from this point up to this particular point, then here will be the 90-degree symbol, that is the right angle. Then here, I'll put theta there, that is the angle. Then you see that this particular place is moving in the y direction, so I'll label here y. This is in the x direction, so I'll move right here x. Now, this particular diagram is now right angle triangle, and the longest side here is my hypotenuse. This side is going to be opposite because the angle is facing that side, and here is going to be my adjacent because the angle is sitting on that particular line. So by using SOHCAHTOA, we can get our trigonometry ratios from this particular diagram. So means sine is equal to opposite over hypotenuse. Can means cos is equal to adjacent over hypotenuse. And TOA means tan is equal to opposite over adjacent. So from the diagram, I can say that sine theta is equal to opposite, which is y, over hypotenuse r. Then cos theta is equal to adjacent over hypotenuse, which is x over r. And tan theta will be equals to opposite y over adjacent, which is x. Also, tan theta is equal to sine theta over cos theta. Because if I take sine over cos, that is y over r divided by x over r. This r will cancel this r, and definitely I'll have y over x, which is the same thing as tan. So tan can be expressed as sine theta over cos theta. Then we also have 3 trigonometry reciprocals, that is cosec, sec, and cot. So the relationship between this particular reciprocal and these ratios are, I can cosec theta is equal to 1 over sine theta. So you see that 1 over sine is the inverse of this particular ratio. So if here I have y over r and I'm to take its inverse, then it will tend to be r over y. Sec theta is equal to 1 over cos theta. But you see that this is the reciprocal of cos. So here, the r will go up and s will come down. So that one is the same thing as r over s. Then cot theta is equal to 1 over tan theta. But you can see that tan is y over x. If I'm to take the reciprocal, it will now be x over y. So these are the relationship of the reciprocals with these ratios. Now, we can now prove these identities by using this right angle triangle, forming using Pythagoras theorem. So from Pythagoras theorem, we can say that adjacent square, that is x square, plus opposite square, y square, is equal to hypotenuse square, which is r square. Let's call this one general equation, which is G. Then we'll now use this general equation to find these particular identities. Now, first, dividing G by r square. So we are going to divide the whole of this equation by r square. That means that here will be x square over r square plus y square over r square is equal to r square over r square. Then you can see that x square and r square, they have the same common power. So I can write it as x over r all square plus here 2 common power, then I'll write y over r all square. But r square over r square is equal to 1. Now, you can see that here I have x over r. I'll come back here to see which of the relations is giving me x over r. X over r is cos. So I can take this one out and write cos. But you can see that this cos is squared. I have to write it down. Cos square theta plus y over r. Y over r is sine. So I can write it as sine squared because of this power, theta, which is equal to 1. And this is the first identity that we have on the board. So this one has been proved. Now, this time around, let's try to divide through equation G by x squared. So dividing G by x squared. So that place I'll have x squared over x squared plus y squared over x squared is equal to r squared over x squared. X squared over x squared is 1 plus, you know that this one I can write it as y over x all what? Squared, which is equal to r over x all squared. Now to continue, I can have 1 y over s. Which of the relations is given now y over s? Y over s, you can see that it is tan. So I'll take it and write tan squared because of the power. Theta is equal to r over s. Which of the relations is given as r over s? You can see that r over s is sec, because sec is equal to r over x. So I can now write sec and square it because of this power, which is theta. Then this is the second identity, which is 1 plus tan square theta is equal to sec square theta. Now, we'll prove the third one. Then this one we are going to divide through by y squared. So dividing G by y squared. It means that I'll have x squared plus y squared is equal to r squared, or this over y squared over what? Y squared. Then x squared over y squared, I can write it as x over y all to the power 2. Here, y squared over y squared is 1, which is equal to r over y all what? Squared. Now let's go back and see which of them is giving me x over y. X over y. You can see that x over y is cot. So I can write here cot squared because of the power theta plus 1 is equal to r over y. Which of them is giving me r over y? You can see that r over y is cosec theta. But I'll write cosec square. Cosec square because of the power here, theta. And this one too is the third identity. So this is how we prove the 3 trigonometry identities equations. That is cos square theta plus sine square theta is equal to 1. And the second one is 1 plus tan square theta is equal to sec square theta. Then the last one is cot square theta plus 1 is equal to cosec square theta. This is how we just use trigonometry to play around these particular equations. Now, thank you for watching this video. If this is your first time of watching, kindly subscribe to my YouTube channel, Nabla Online Maths, so that you'll be notified anytime a new video is being uploaded. You can also share my Facebook post for others to watch. On TikTok, you can follow me by searching for Prof Nabla. I'm on TikTok by that particular account. Next time, we are going to learn how to simplify trigonometry expressions. Thank you once again and have a nice day. Bye-bye.